This video is for the second half of the note sheet 9.1b, multiplying and dividing rational expressions. Notice the steps for simplifying complex fractions. A prep step would be number one here, that if you need to, make sure to simplify numerators and denominators using the least common denominator, and that'll look like the third example that I go over. For the most part, however, you'll see examples that look like the one below, where you simply just multiply by the reciprocal of the denominator and simplify from there using what we learned in the first half of the lesson. So our direction is to simplify. We won't have to do any exclusions because we could assume that all expressions are defined. So in the first example, if you need to, you could rewrite the divisor, the fraction in the denominator, to the right using the division operation symbol. And now it'll look like the previous page of notes, where when you divide by a fraction, you multiply by the reciprocal of the divisor. You could also start at this step once you realize that division by a fraction is multiplication by the reciprocal. So now we factor, and then we will divide. Please note that in the second denominator, it's not in standard form, so let's rewrite it in descending order. At the same time, I'll factor out a -1. So what we used to have was simply -x plus 4, and then I went ahead and factored out the -1. My next move is to divide out like factors, so the x's divide out. So then we have 2x plus 1 all over negative of x minus 4. And by putting it in descending order and then factoring out the negative like I did there, it didn't reveal any common factors between the numerator and denominator. So I could either leave the answer like this, or equivalently I could put the negative out front, distribute it through in the numerator, or distribute it back through in the denominator. Any of those would be acceptable answers. Looking at our next example, we see again that we're dividing by a fraction, and that's what makes this a complex fraction. And dividing by a fraction is the same thing as multiplying by the reciprocal. And any time that I make a move, I'm going to simplify whatever I can. So I factored the numerator of the first fraction. Now I go ahead and divide out like factors. 4 and 8 twice. And then multiply numerators together. And it would be all over 1. So I could leave my answer as 2 times x plus 3. Please note a shortcut that numerators divide with one another and denominators simplify with one another. So if I wanted to at the very beginning, I could take the 4 out of the 8 right away, and I could rewrite the x squared minus 9 as x plus 3, x minus 3, and then there's less writing, because now I could go ahead and, because this is a numerator and this is a numerator, I could divide them out. So now the problem really just simplifies to x plus 3 divided by 1/2, which is the same answer. Just something to consider. We'll now look at the third and final example, which is a little tricky. Check out that numerator. It's not one combined fraction, so that will be our first step. I'll do that off to the side, asking what is the least common denominator of x and 2? And the answer is 2x. So if I went step by step here, I'll use the shortcut first, and then I'll fill in the steps that were skipped. I'm looking for least common denominator of 2x, so I go ahead and I make that the denominator. And then I realized that I would have to multiply the denominator as well as the numerator by that 2 to get 3x to be an equivalent fraction with a denominator of 2x. So in other words, I could just write that 3 in the numerator and multiply it by 2. And then the operation between them is addition. And I could just write that x, and then I can multiply it by the factor in its denominator that's missing compared to the least common denominator, and that factor is an x. So in this way, I could rewrite my complex fraction as 3 times 2 plus x times x as 6 plus x squared all over 2x, and that's in the complex fraction with x minus 1 all over x. Now it's best to combine individual fractions in one part of your complex fraction before you proceed and multiply by the reciprocal of the divisor. And now it's routine from here. So because I'm multiplying, I could divide numerators with denominators. So I have a final answer of x squared plus 6 all over 2 times the quantity x minus 1. No further simplifications occur.